Alrighty, well, welcome, and today this is a workshop over problem solving and word problems, and we're going to go over some examples, at least one example, to maybe kind of wrap our head around word problems. But oftentimes in the center we get this kind of confusion or disdain even for word problems, and what we want to do is maybe try and reduce that anxiety and those negative feelings, and just kind of approach it more step by step. So, when we're doing problem solving, I've got an example here we'll get to in a second, but we're doing problem solving, and in your book on page 104 there's this purple box that gives you a great kind of interpretation on how to approach this. And I'm going to add a little bit to it. So the first one it says is understand. If I switch between cursive and print, pardon me, I kind of doing both. Understand the problem, and what that kind of entails is reading the problem and then reading it again. So that's the thing, read and then read again. And that's okay, take the time to read it, take the time, don't rush, you've got all the time in the world. That's what I'm telling myself right now too. So read it, try and understand it. Another thing that's important here is context, right? If you're in section about 2.3, 2.4, you can kind of look around, maybe 2.5, and see what's going on. And you can probably get an idea of the kinds of problems to expect, even if they're word problems. The second step that it gives you is the idea of translation. So you want to be able to translate these kinds of words and these whole big old phrases into mathematical concepts that are easy to understand. This isn't just true in math. You can have to do this sometimes in psychology. You'll have to do this in chemistry or physics or economics, anything like that. These kinds of problems don't work just for math. So translating, getting it into context of what you're working on at that time. After that, the translation is the hardest step, simply because it's getting those words and those important facts out of those kinds of word problems and onto paper, which is a little bit easier to deal with. Then after that, you're down to solving, which isn't so bad, and then lastly, interpreting. So an interpretation is mostly supposed to be along the lines of, does this answer make sense in the context of the problem? Sometimes, like for example, if you're doing a certain math problem and you're dealing with time, if you get a negative number that really doesn't make sense, and you might want to double check, or maybe sometimes throw that answer out. It happens. So I've got this problem over here that I thought up at the last minute. A bowling league states the following rule, and this is something that you see in bowling all the time. Handicap. So a bowler can get a certain amount of handicap to help, equal out the good bowlers from the bad bowlers. Handicap is 90% of the difference between 220 and a bowler's average. And the problems that we have here are, one, to write an equation to represent the rule, and two, what is the handicap for a bowler with a 130 average or a 190 average? And we can kind of play with this once we get started. So I'm going to erase this. And if you've got your book on next to you when you're kind of keep following along, keep that page 104 handy so that we can work our way through this. Alrighty. So I read it once, so now I'm going to read it again. A bowling league states the following rule. Okay, that's fantastic. It's contextual, but it's not something I need too much for the sake of translation. Handicap is, if you have that handout that a lot of teachers will give out on the translation, is means equals. So I've got an equal sign there. Is 90% of, okay, well I've got another small phrase here. That's a little different. So 90%, so I'd have to convert that, which means 0.9. And of, most of the time, means multiplication. Well, is would mean, let me erase that right there, but equals right there. So there's that and that. 90% of the difference between 220 and a bowler's average. So I see difference, but it's not 90 minus anything necessarily. It's more of the idea between, you have to take the difference between 220 and a bowler's average first So the trick is we have to put parentheses up, because if it's telling us to do the difference and then do 90% of that, we need parentheses. And we have a 220, which is a constant, and a bowler's average, but not all bowlers are the same. Some bowlers bowl really well, some bowlers bowl really poorly, which means that's kind of independent of what we're dealing with. So I'm going to call that X. But, and here's something that you don't always see a lot of instructors doing, and I would strongly recommend it. I'm going to come over here to the side. I'm just going to write it down. X is a bowler's average. And sometimes we care about units. In this case, it'd be in pins, because we're talking about bowling. Of course, if you were talking about golf, it would be strokes, or other sports that I'm not terribly familiar with that have handicaps, but I'm sure they all do. But if I at least say what this is, I can now identify that that's the bowler's average. And now I know where to put it. And by writing it on paper, you get it out of your head. So I've handled all that except for the very beginning. Handicap is. So if I've got an X for bowler's average, I might want to do Y for handicap. So then I'll come over here and I will call that handicap. Once again, that's going to be in pins, because you add the two together. They're supposed to be the same units. You can add stuff that have the same units together. And that's it. Bam, we have now gone through not only step one, understanding the problem, but we've also gone through the translation of the problem. And now we've got some sort of linear idea. It's linear because there are no x squareds or anything like that, and that'll be covered later in probably another workshop. And then y as the outcome variable. And now we can actually start working on these guys. We did number one already. That's part of the translation. So a lot of the times you want to do that before you even consider anything else. And now it's not so bad. What is the handicap for a bowler with a 130 average? So I have to say, okay, that's an average, not a handicap. So I come back over here. Bowler's average is X. So I put that in for my X. 0.9, and I just write everything exactly the same. 130 equals Y. And now I've got just a whole bunch of arithmetic to solve this out. 0.9, I'm going to do parentheses first because of order of operations. 220 minus 130 is 90 equals Y. And you know what? I'm not terribly confident about multiplying these side by side, so I do what's called side work, where I'll just kind of work that out on my own without messing with the flow of how I'm solving this problem. So I have 90 times 0.9, and I'll just go and work that out. That's a 0 that way. 9 times 9 is 81, and I have one number behind the decimal, so 81. So Y equals 81. Now, if we want to remember to put our units back in, that is pins of handicap. Not so bad, not so bad. And that's how we answer that. So that was the answer for that guy, and we're almost done. So if we have this difference here, 81 plus 130, well, that's almost 200. That's a little over 200, actually. It's not quite 220, though, and that's because of the 0.9. So when you're multiplying by a decimal, the closer you get to this number in this kind of a case, the less pins you lose, because you have a lower average. So 81 pins of handicap. Now, I'll go ahead and erase this, and I'll just do the last guy. This leave my model. We tend to call this guy here our model, which is helpful to have that term. And we'll just replace the X with a 190. So this person has got an average of 190, which means for every game they bowl on average a 190. Maybe they're a little less one game, a little more another game, on average 190. Which means this person should have less pins than the 81 we found in part 1. So same idea as before. 220 minus 190, well, that's only 30. Don't need that parenthesis that far over. Alrighty. Same idea. I don't like the idea of trying to do a lot of work here, so I come over here and I do my side work again. 30 times 0.9, still 0, that would be 27, and that's it. So y is 27. Don't forget the units. All right. So we can do that. Now, this 27 plus the 190 is probably more than the average of 130 plus the 81. And that's, once again, because of that 0.9. You'd be surprised how many bowlers who do this for years and never understand that idea. So that handles that. Now, we can do one more thing just for fun. I'm going to erase that. And I'm going to say, what if the handicap is, let's say, maybe, oh, I don't know, how about 45 pins? If the handicap is 45 pin, what is the average? And I'll put a question mark there to tell me that's what I don't yet know. Well, in that case, I have to turn things around a bit. So if my handicap is 45, kind of break that off to the side there. Y is my handicap in pins, so I got to put that on the Y side. So 45 equals 0.9 times 220 minus x. So I've now translated that into that equation. And now I've got a couple options. I could do something, I could maybe distribute this 0.9 in to that, or I could divide the 0.9 to the other side. It doesn't matter how you go, and that's what's nice about this, because if you're either going to be multiplying or dividing, they can be done in any order. So the first thing I'm going to do is I'm going to convert this to a fraction, just because that's kind of hard for me to deal with. That way I don't have to worry about decimal place. Okay, so 0.9 is 9/10, so 9/10 for our fraction there. And now I can clear my fractions because I only have one denominator, and the denominator is 10, so I'll multiply by 10 to both sides. Neat trick about tens is if you multiply that, you just simply, for every 0 you see, you add a 0 to what you're multiplying to. And our tens here will clear. Now we just have 9 times 220 minus x. And because I don't really want to do that multiplication, that's a lot of work. I get really large numbers here that I'm going to have to move later. I'm going to go ahead and divide by 9. And I didn't actually see that until I got here, which is okay. You don't have to have full insight into where you end up. You just have to keep doing a step at a time. Well, 9 doesn't go into 4, but 9 does go into 45, and it goes in 5 times. And it goes into 0, 0 times, but it does go in evenly. Now we've got 220 minus x. Alrighty, I'm running a little short of room, so let me erase this real quick. Okay, so we got a negative variable. We never want the negative variable, and different people handle this different ways. I like to just take the time and add that to the other side. But they're not common terms, so I just have to write them next to each other. X and 50 is positive, so there's x plus 50 equals 220. And I'm getting very, very close to being done. So subtract the 50, subtract the 50, and x is, well, that becomes a 1. That becomes a 12. So we got a 0 there. 12 minus 5 is 7. And the 1 carries down, which means if a bowler has a handicap of 45 pins, that means that their average is about 170. Exactly 170 in this case. But the idea, once again, is to first start at the very beginning. Read the problem once. Just kind of get an idea of the context that you're in. Then read it again and start looking for those key words. Handicap is. Of is another one of those words. Difference is another one of those words. Kind of one of the most tricky things that we see for students is that when they see this word, they immediately think plus. But the thing is, that's already been qualified by the difference. It's supposed to be the difference between 220 and an average. So the difference overwrites that and there. And then when I went backwards afterwards, and I tried to declare my variables, and this is called variable declaration over here, this x equals an average and y equals a handicap. well, I think that's all I have for today, so thank you very much. I hope you found this informative, and I hope you enjoy the other workshops that we're providing. Thank you.